As we've talked about solving polynomial equations, what we've learned is that we can factor them. And if we factor them completely, we set each factor equal to 0. But sometimes they can't be factored easily, so we learned that we could use synthetic division in order to help us factor a polynomial. But that implies that we know one of the factors. So then we watched a video on how to use the rational root theorem to find one of the factors. However, the rational root theorem actually just tells us that there can be a large number of possible factors, both the positive and the negative. And we need then to find a way that we can narrow it down so that we don't have to spend an exorbitant amount of time guessing and checking each one and hoping that we're lucky enough to find one really fast. So that brings us to Descartes' rule of signs. Descartes found that there is a rule that helps us to narrow down the real roots of a polynomial. Let's take a look. What we know and what Descartes found out is that the number of positive real roots to any polynomial is equal to the number of sign changes between consecutive terms in the polynomial, or it's less than that number by an even number. So if I found 5 sign changes in my polynomial, that means that I have either 5 positive real roots, 3 positive real roots, or 1 positive real root. But I have to have at least 1 positive real root. Well, that means that I know I could start by checking some positive real roots, and I have to have at least 1 of them. But there's more to Descartes' rule of signs, because he found also that the number of negative real roots is equal to the number of sign changes between consecutive terms of p of negative x, or less than that by an even number. P of negative x. Let's review something real quick. When we're working with polynomials, the first thing we always want to do is start with it in standard form. Well, that's pretty easy to do, put it in standard form. It's decreasing order of exponents. And the positive real roots, well, it just deals with positive x. But the negative real roots deals with p of negative x. What does that mean? Well, it means that we're going to rewrite the polynomial substituting negative x in place of every x, and then simplify it. And then with that, we can count the sign changes between consecutive terms to find out how many negative real roots we'll have. Let's take a look at an example. I have p of x. P of x equals 6x to the 4 minus 13x cubed plus 13x squared minus 39x minus 15. Now, this polynomial might look a little bit familiar to you. It's the same one we used when we were looking for those possible rational roots. And remember, there were quite a few of them. So let's see if there's a way we can narrow it down using Descartes' rule of signs. So Descartes' rule of signs said that we can find the number of positive real roots by counting the sign changes between consecutive terms. Well, what do we mean? Well, let's take a look here. If we're looking at the sign changes here, we know that this is positive 6x to the 4 minus 13x cubed. That's a sign change. And then negative 13x cubed plus 13x squared, that's another sign change. And positive 13x squared to negative 39x, that's another sign change. But then we go to negative 15, that's not a sign change. So that means that we have 3 sign changes. Well, what does that mean? That means that we either have 3 positive real roots or we have 1 positive real root. Okay, but then there was something about this negative x. P of negative x, well, remember we said that that means we're going to replace every x in our polynomial with a negative x. So we have 6 times negative x to the 4 minus 13 times negative x cubed plus 13 times negative x squared minus 39 times negative x minus 15. But remember we said we have to simplify that. What does that mean? Well, what is negative x raised to the 4th power? Well, a negative times a negative times a negative times a negative has to be positive. So what exactly does that mean? It means it simplifies to this. P of negative x is equal to 6 times x to the 4 plus 13 times x cubed. How did we get that? Well, a negative cubed is still a negative, and a negative times a negative is a positive. In other words, negative x cubed is negative times x cubed, and negative times negative is positive. Negative x squared is positive, so it's still plus 13x squared. Negative x times negative 39 is positive. And then the 15 doesn't change, so it's still negative. So now what we want to do is count the number of sign changes. We have a positive to a positive, the sign didn't change. To a positive, the sign didn't change. To another positive, the sign still didn't change. To a negative, so we have one negative sign change. Well, what does that mean? That means that we either have 3 or 1 positive real root. And we have 1 negative real root. So what does that help us with? Well, if we went back and looked at our notes from the last video, and we looked at all the possible rational roots for a polynomial, what we know is that we can narrow down those roots that one of the negatives has to be real, and either 3 or 1 has to be positive. So 1 negative and either 3 or 1 positive. So that kind of helps us narrow it down a little bit more. When we move on, we're going to take a look at how do we actually find those.